the energy possessed by the body due to the virtue of its motion or position or configuration. There are two types of mechanical energy. One is kinetic energy and one is potential energy. Suppose I have an object, the initial velocity of the object is u. When object is moved with certain force, say F, work is related to energy. We got to know that if work is done, energy has been transferred. So work energy theorem for a constant force. Hello everyone, I am Nishma Nanjamma, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome back to my session 2 on chapter 6, Work, Energy and Power. In this session, let us discuss what is energy, what is SI unit and dimensional formula for energy, and also we shall study two types of energy, kinetic energy and potential energy, and derive the expression for kinetic energy, and also let us look at the derivation for work done by a constant force, work done by a constant force. So, in today's session, to begin with energy, what do you mean by energy? What do you mean by the term energy? It is a measure of work done. Energy is a measure of work done. Work done is denoted by alphabet W. In the previous session, we have already discussed what do you mean by work. Work is a product of force and displacement vector. Work is a product of force and displacement. So, the definition of work in physics reveals its relationship to energy. The definition of work in physics reveals its relationship to energy. Work is done, then we say energy is transferred. If work is done, then energy is transferred. Say, suppose take an example. We walk, we push or pull an object. We have an object. We push or we pull the object. We push or pull the object. What we are doing? We are applying some force. When we apply some force, we say we are doing some work. We are doing some work on the object. When I apply force, what happens? The object is displaced from one position to another position. So when displacement is there, we say work has been done. That means when we apply force, we are doing some work. When we apply force, the object is displaced from one position to another. So we say work has been done. Energy has been transferred. So what do you mean by the term energy here? It is the capacity of the body or capability of the body to perform work. It is the capacity or ability of the body to do work is called energy, and energy is similar to work, is measured in terms of joule, and dimension formula of energy is same as that of work. It is mL to the power 2 T to the power minus 2. So this is dimension formula and SI unit of energy. We come across different types of energy. It might be heat energy, sound energy, mechanical energy, potential energy, kinetic energy, etc. In the next session, we'll discuss all the types of energy in detail. For now, in today's session, in this chapter, we'll study more about mechanical energy. Mechanical energy, because mechanical energy is the sum of U plus K. What do you mean by this? Mechanical energy is sum of U plus K. So what is U and what is K here? Mechanical energy is a sum of potential energy represented by U and kinetic energy represented by K. So the energy possessed by the body due to the virtue of its motion or position or configuration, there are two types of mechanical energy. One is kinetic energy and one is potential energy. Kinetic energy plus potential energy is called mechanical energy. In this chapter, we come across through kinetic energy and potential energy. That means we study more about mechanical energy in this chapter. In this session, we are deriving the expression for kinetic energy. So let us try to understand what do you mean by kinetic energy and potential energy. When I talk about kinetic energy, there is a motion coming into picture. There is motion coming into picture. A moving body possesses kinetic energy. Example, flowing water, a bullet fired from a gun. So a moving object possesses kinetic energy. Energy possessed by the body by virtue of its motion is called kinetic energy. Energy possessed by the body by virtue of its motion is called kinetic energy. Similarly, we have potential energy. Potential energy is also called as stored energy. It is the stored energy. Potential energy is nothing but the stored energy. Energy possessed by the body. The energy possessed by the body by the virtue of its position or configuration. By virtue of its position or configuration is called potential energy. A water stored in a tank at certain height is an example for potential energy. So kinetic energy is mathematically represented as half mv square, where m is the mass of the body, v is the velocity of the body, and potential energy given by U is equal to mgh. Is represented by mgh, where m is the mass of the body, g is gravity, is the value of acceleration due to gravity, h is height of the body. So this is about kinetic energy. When we talk about kinetic energy, motion comes into picture. A motion term is involved in kinetic energy. When we talk about potential energy, it is the stored energy in the body given by U is equal to mgh. Say, suppose take an example. I have a water stored in the tank. Which is placed at a certain height h from the ground. It is stored at certain height. I have an example of a water tank where water is stored in the tank which is placed from certain height h from the ground. So the energy possessed by the water tank is nothing but the potential energy, because it is the stored energy. We are doing some work in order to place the water tank from the ground at certain height. So that work done is stored in the form of potential energy. As the potential energy decreases, as height decreases, when water starts to flow from the tank, the height decreases and potential energy is lost, and water gains kinetic energy. Because motion is coming into picture. How the kinetic energy is gained here? Potential energy loses and gave rise to kinetic energy because height keeps on reducing. So we are doing some work against the gravity of the ground in order to place the tank at certain height h. So that work done against the gravitational force is stored as a potential energy. This stored energy, it is at rest. So initially the velocity will be 0. Then once the water starts to flow, you can see the flowing water is an example for kinetic energy. So it gains kinetic energy because height keeps on decreasing. Potential energy will be lost. So water starts to flow with velocity v. It gains kinetic energy. So this is about kinetic energy and potential energy. In the next coming sessions, we'll discuss in detail about potential energy. Now let us concentrate on kinetic energy for today's session. So what is kinetic energy? Kinetic energy of a body is the energy possessed by the body by virtue of its motion. It's important. By virtue of its motion is equal to the work done by force acting on a body, is equal to work done by the force acting on the body in order to change the state of rest or state of uniform motion with a particular velocity. So kinetic energy is given by K is equal to half mv square. So kinetic energy of the body is equal to half into mass of the body into square of the velocity of the body. Say suppose I have a ball. I have a ball which is moving in a forward direction. I have a ball which is moving in a forward direction. The mass of the ball is 10 kg and it is moving with velocity say 10 meter per second. For example, it's 10 meter per second. So what is the kinetic energy possessed by the ball? How do you calculate the kinetic energy possessed by the ball? The mass of the ball is 10 kg. It is moving with velocity 10 meter per second. 10 meter per second. Now, what is the kinetic energy? The value of kinetic energy possessed by the ball, because it is moving, it is in motion. So, it will have kinetic energy in it. So, what is that kinetic energy? How do you find the kinetic energy? So, we'll mathematically derive the expression for kinetic energy. So, example for kinetic energy is a moving car, flowing water, a bullet is fired from the gun are example for kinetic energy, because moving objects possess kinetic energy. Say for example, to prove it mathematically, consider I have a object. Consider I have an object which is initially at rest. It is at rest condition. So initial velocity u is equal to 0. It is at position A. It is at position A. Now what I'll do, I'll apply some constant force F. I will apply some force F. So what happens? The object starts to move in the forward direction. The object starts to move in the forward direction. Why? Because I'm applying force. Because I'm applying force. So it starts to move with some velocity. It will move with some velocity. When it moves with some velocity, that means there is kinetic energy possessed by the object and it acquires final velocity v. It reaches to point B and it acquires final velocity v when it is displaced. So the object acquires velocity v after the displacement s, after it undergoes displacement s. So this is my final velocity. So this is my initial velocity. Suppose I have an object, the initial velocity of the object is u. When object is moved with certain force, say F, when the object is moved with certain force, say F, the object starts to move in the forward direction. That means it starts to acquire some velocity. When object starts to move with some velocity, that means object possesses some kinetic energy. Object possesses some kinetic energy. Then object acquires the final velocity v when it reaches the position B after it undergoes the displacement S. Now what is the work done? There is some work done in order to move the object from position A to B, in order to displace the object from position A to B. Now what is that work done? So we know from the previous session, work done is a product of force and displacement. Work done is a product of force and displacement. So this is the definition of work that we all know. Now I want to know what is the value of force and what is the value of S in order to substitute in equation 1. So I'll get what is my work done. So how will you find F and S? So consider third equation of motion to find out the value of S, because third equation of motion is independent of time. So I'll consider the third equation of motion which we have studied in the previous session, that is v square is equal to u square plus 2as. V square is equal to u square plus 2as. So v square minus u square is equal to 2as. I want what is S. So S is equal to V square minus U square. Bring the 2S to the denominator. So this is my second equation which gives me the value of S. Now I got S. I want to know what is the value of force now. I want to know what is the value of force. So how will you get force? You can use Newton's second law of motion. Consider Newton's second law of motion. Consider Newton's second law of motion. So from Newton's second law of motion, I know force is a product of mass and acceleration. So substitute F is equal to ma. This is my third equation. So substitute 2 and 3 in equation 1. Substitute 2 and 3 in equation 1. So your work done W is equal to, what is force? It is ma. And what is your value of S? Displacement, it is V square minus U square divided by 2A. So 1A cancels with 1A. So what is remaining? It is half m V square minus U square. Half m V square minus U square. And we know initial velocity U is equal to 0. Why? Because the object is initially at position A, it is in the rest condition. So it doesn't have any initial velocity. So initial velocity is equal to 0, then my work done will be W is equal to half mv square, because U is 0 here. So this is nothing but work done is equal to kinetic energy. K is half mv square. Work done is equal to kinetic energy. I can say work done is equal to kinetic energy. So if a body is moving with some velocity v and it has some mass m, it will possess kinetic energy equal to half mv square. If a body is moving which has some mass and if it is moving with some velocity v, so the kinetic energy will be possessed by the body, that is equal to half mv square. So this is the expression for kinetic energy, where we have seen work done is equal to kinetic energy possessed by the body. So a simple derivation where kinetic energy is the energy possessed by the body by virtue of its motion. So kinetic energy examples are moving car, flowing water, where the motion is coming into picture. So to derive the expression, I am considering a image here. I am considering image where initially the object is at rest, that initial velocity u is equal to 0. Now I'll apply some force, so object starts to move in the forward direction. When it starts to move, means it is coming into motion, it is moving with some velocity v. So when it moves with some velocity v, the body will possess some kinetic energy, because moving object possess kinetic energy. So the final velocity acquired by the object is v after the displacement s. So there is some work that has been done in order to displace the object from position A to position B. So what is that work done? That is equal to, from the previous session we know it's a product of force and displacement. I don't know the value of force and displacement. So using the third equation of motion and Newton's second law of motion, I will find the value of F and S and substitute that in the equation 1. So I will get it as W is equal to half m of v square minus u square, final velocity minus initial velocity. I know initial velocity at the rest state is 0. On simplification, I'll get work done is equal to kinetic energy possessed by the body. So next I have work energy theorem for constant force. Work is related to energy. We got to know that if work is done, energy has been transferred. So work energy theorem for a constant force. We'll also study work energy theorem for a variable force in the next session. For today's session, we shall concentrate on a constant force. What do you mean by work energy theorem by a constant force? That means I am applying constant force on the object to move from one position to another. The magnitude of force is not changing. It is constant. So look at the image here. Similar explanation that I had for kinetic energy. I have an object which has, this is an object which has certain mass m. It is moving, it has certain mass m. The initial velocity, initial state, the velocity of the object is u. So I'll apply some constant force. I will apply some constant force on the object. So the body which has mass m will start to move in the forward direction. So when I apply constant force, the object is moving with some velocity v. That means a moving body possesses a kinetic energy. So it involves kinetic energy in it. So when it reaches the final state at B, the velocity acquired by the object which has mass m is v after the displacement s. The similar explanation that we had for kinetic energy. So I'm applying constant force, so the object starts to move with a uniform velocity, so it will possess some kinetic energy. I know it has some kinetic energy. The final velocity acquired by the object will be v after the displacement s. So I'm doing some work in order to displace the object from one point to another point. So this is an explanation of the diagram given towards your right. So what does the work energy theorem principle states? What does the statement mean? So the change in kinetic energy of the body. So kinetic energy, you can see the object is possessing some kinetic energy as you apply constant force. The change in kinetic energy of a body is equal to work done on it by a net force. That means by a constant force. I am applying a constant force in order to displace the object from one position to another position. So work has been done to change the kinetic energy of the object from initial to final state. So at each point there is a change in the kinetic energy. When it moves with a constant force, so it has moving with some velocity. So at each point there is change in kinetic energy. So to derive the expression, I will consider third equation of motion. Consider third equation of motion. Consider third equation of, which is that third equation, v square is equal to u square plus 2as. Final velocity, initial velocity plus 2, a is acceleration, s is the displacement of the body. So from the equation, it reduces to v square minus u square is equal to 2as. So it will be in this form. Now multiply both RHS. Now multiply both RHS and LHS by a factor m by 2. Multiply m by 2 on LHS as well as RHS of equation 1. So what you will get? It will be m by 2 v square minus m by 2 u square is equal to m by 2 2as. So what happens? 2 and 2 get cancelled. So it will be half mv square minus half m u square is equal to m-a-s. So what is m-a here? F is equal to m-a from second law of motion. From second law of motion, I know F is equal to ma. So substitute that here. So you'll get half mv square minus half mu square is equal to F yes. So what is F dot S? That is equal to W, work done. We know this expression is for work. F dot S is equal to W. So substitute that here in the previous equation. You'll get half mv square minus half mu square is equal to W. So kinetic energy in the final state minus kinetic energy I am writing it as Ke to the base, I am writing it as F. That means kinetic energy in the final state. We have V here. Kinetic energy in the final state minus kinetic energy in the initial state is equal to work done on the object. So final minus initial is nothing but final minus the initial velocity will give you change in velocity. So that will be, I can write it as change in kinetic energy, KE. Change in kinetic energy is equal to work done. Change in kinetic energy is equal to work done. So change in kinetic energy of the body is equal to work done by the net force. We have proved it mathematically. Change in kinetic energy is equal to work done. So what is this? Work energy. What is the work energy theorem statement? States that the principle of work energy theorem is change in kinetic energy of a body is equal to the work done on it by the net force. That's the constant force. So mathematically we derived the expression for work energy theorem for a constant force, on application of constant force. So very important. It is a very important theorem which you can expect for 3 marks. Please keep in mind a very important concept, work energy theorem for constant force. I've considered the third equation of motion, from which I have equation 1. In equation 1, what I'll do, I'll multiply m by 2 to both the sides, RHS and LHS. So I will get the equation as half mv square minus half mu square is equal to mas. What is your ma here? It is F is equal to ma. We know from second law of motion, Newton's second law of motion. So I'll get half mv square minus half mu square is equal to F dot S. So what is F dot S? It is work. It is representing work. So on substitution, you'll get half mv square, final velocity, minus half mu square, initial velocity, is equal to work done. So kinetic energy, half mv square is what? It's kinetic energy. It is v square. It is u square. So kinetic energy final minus kinetic energy of initial state is equal to work done. So final minus initial is giving us change in kinetic energy. So I have written delta symbol here. Delta, change in kinetic energy, is equal to work done. So we have proved it mathematically. That's all for today's session. In today's session, we discussed what is energy. It's a measure of work done. So energy is the capability or ability of the body to perform or do work. It has a similar SI unit and dimension formula as that of work. The SI unit for energy is joule and dimensional formula for energy is ml to the power 2 t to the power minus 2. And we discussed about mechanical energy, which mechanical energy is a sum of kinetic energy plus potential energy. What is kinetic energy? It is the energy possessed by the body by virtue of its motion. So potential energy is the stored energy. So kinetic energy of a body is equal to half mv square and potential energy of the body is equal to U is equal to mgh. And after that, we derived expression for kinetic energy with mathematically, and we proved that kinetic energy equation is half mv square. We made some consideration and we proved kinetic energy. The examples are moving car, flowing water, etc. Next, we came up with work energy theorem, which states that kinetic change in kinetic energy of a body is equal to work done on it by a net force. So according to the statement, we proved the theorem by applying a constant force, that work done is equal to change in kinetic energy. So next, I'll come up with more interesting session on work energy and power, where we'll study something about variable force. What is work energy theorem by variable force? Until then, take care. Have a good day. Thank you.